All right, this is the third video in Unit 6, and we're going to talk about translations of graphs of sine and cosine. So in order to get good at finding a function giving a sine and cosine graph, you really kind of have to be somewhat proficient at graphing these. And so the good news is that I am going to show you kind of a nice approach that you can work with, but for doing that, let me just throw out an example so that we can start thinking about how to approach something like this. So remember what we've done so far in terms of a transformation. We talked about when we multiply the outside of the trig function by a particular value, cosine. What does that do? Well, that vertically stretches or shrinks the graph, and that tells you the amplitude. So the amplitude is the absolute value of A. And when we multiply our variable, our x variable, or the variable associated with our domain by a value inside that trig function, that's going to affect the period. It's going to either horizontally compress or slash shrink, or expand the graph. And so the period is going to be 2 pi, what normally, if b was 1, and there was, normally the period would be 2 pi, and then you're going to divide it by that b value to find the new period. And something that I find helpful is once I know that new period, then it's helpful for me to find the interval width between the angles I'm going to plot. So the interval width is always going to be the period divided by 4. Okay, so let's add a couple of other types of transformations. The easiest being if I did something like this, so plus c, or actually I'll say plus c, or y equals a cosine bx plus c. What do you think that c is? Well, that's like it always has been, a vertical shift. And so that'll change our midline. So thus far, our midline, or we can think of that equilibrium, has been the x-axis, but that'll change if we, outside that trig function, if we are adding or subtracting some particular value. So the vertical shifts tend to be easy, again, a range effector. When it becomes complicated is when we talk about something like the following. So let me give you an example, and then we will generalize. But what if I had -1 plus sine 4x plus pi? Or in other words, if you don't like that -1 in front, actually I'm going to say 2 sine. This is the same as writing 2 sine 4x plus pi minus 1. So the vertical shift, down 1. All right, but this 4x plus pi, it's bothering me. So if you think about setting that equal to a particular value, let's set it equal to, because normally we would plot 0. Well, what do I have to put in for x so that I'm taking the sine of 0? And to figure that out, you set the inside equal to 0, and this gives you an idea of what's happening. And what's happening is I'm subtracting pi, so I can think I'm going to the left pi, and then I'm shrinking by a factor of 4. So instead of putting in 0 first, I'd put in -pi/4. And you could do that for all the quadrantal angles. I find an easier way to do it, and we did this a little bit with transformations, either last year in Algebra 2 or this year, is normally when I graph without a period change and without this plus or minus something, which we'll talk about what the heck that is. Normally we'd to do one period, we'd start at 0 and do evaluate all the quadrantal angles up to 2 pi. Well, let's see with this transformation, I'm going to set what's inside sine between the extremes of that one period that I normally, if there was no change, would graph. And this orients me on what would be if I solve for x here, this is the first angle I'm going to plot to get one period, and the last angle I'm going to plot, subtracting pi and dividing by 4, is pi/4. So I a lot of students I've found over the years like to kind of organize this in a bit of in a table, and so they say, all right, my x values given this period change and this shift, this horizontal shift here. I'm now, in order to really be evaluating my quadrantal angles, I have to plug in negative pi over 4 to start, and the one corresponding to 2 pi will be pi over 4. Well, to figure out what all the angles that I'm going to plot to get one period are, I'm going to go back to this function and remember our b value that we talked about before. It's what's in front of the x. That's going to help us figure out what our new period is. So in this case, our period is going to be 2 pi over 4, or pi over 2. Okay, and what else I said was helpful is to find how far apart the angles I'm going to plot are. So my interval width in this case is the period, pi over 2, divided by 4, or pi over 8. And that's helpful now because when I go back to my table here, if the first angle I'm going to plot is negative pi over 4, the next angle is going to be pi over 8 away from that. So if I do negative pi over 4 plus pi over 8, that's going to give me negative pi over 8. If I add pi over 8 again, I'm just going to erase this a little bit. If I add pi over 8 again, I'm going to get 0. Add pi over 8 again, and then add pi over 8 this last time, which, voila, that's good. And the point of doing that was if you've done it correctly, when I plug in x to 4x plus pi, I should be getting my quadrantal angles. I should be getting 0, which I do in this case, and I should be getting pi over 2. Just going to eyeball and double check. I do. I should be getting pi. I should be getting 3 pi over 2 and 2 pi. If I found these angles correctly, that should be the case. Because then I know that when I take the sine of 4x plus pi, meaning I'm going to be now evaluating my quadrantal angles, it goes 0, 1, 0, negative 1, 0. And then remember, with range changes, we're going to follow the order of operations, which means I'm going to multiply my y outputs by 2. So I've got 0, 2, 0, negative 2, 0. And then I'm going to take all those y outputs and subtract 1. So from what I just got, I'm subtracting 1. And I've got negative 1, 1, negative 1, negative 3, negative 1. And so this first line here in the table are the x values I'm going to plot that reflect one period. And this last is the corresponding y values. So when I then go to graph this, all right, so you just want to be careful about plotting with, particularly if 0 isn't one of the angles you're initially plotting. It is in this case, so I have to be less careful, but you just want to make sure your interval width is consistent. So pi over, oops, meant to put pi over 8 there. Negative pi over 4, pi over 4. Okay, and we could continue. We could keep on doing this. 3 pi over 8, pi over 2, which is 4 pi over 8, and so on. Negative 3 pi over 8, negative pi over 2. Okay, now one thing I find helpful, just personally in terms of making sure my graph visually doesn't look too bad, is I go to the vertical shift, which is negative 1 in this case, because that's going to be my new midline. So I tend to draw a dotted line there just to make sure my graph is equidistant above and below that. It's just helpful for me when drawing and to make sure when I eyeball it, it looks correct. All right, so we're saying at negative pi over 4, we're at negative 1. So negative pi over 4, negative 1. And then at, let me just draw all these in. And then at negative pi over 8, I'm up at 1. Then at 0, I am back down to my midline, negative 1. At pi over 8, negative 3. And at pi over 4, back to my midline, negative 1. And then I can of course, the goal is to be able to continue as much as you would need to be able to see that pattern. So you can continue in the same way. So my transformed graph looks like this. Now, one thing that I want to come back to. So this was the graph we said of y equals 2 sine 4x plus pi minus 1. And we've already said that the amplitude is 2. The period here is 2 pi over 4, or pi over 2 in this case. My interval width is pi over 8. My vertical shift is down 1. But we haven't stated the horizontal shift. So when we which is also going to be called a phase shift. And really, to see what the phase shift is, you want to think about, and this is going to be helpful when going from a graph to an equation. I want to think about after I've implemented my period change, how am I shifting my graph to left or right? And in order to make that order of operations, to see that, I want to factor out the 4. So when I factor out the 4, I'm not taking it out of sine, I can't do that, but I'm just factoring it out, separating it from the x plus pi. So again, I'm just rewriting this middle piece here. And the reason I'm doing that is if we were talking about kind of rewriting points here in terms of the order of my transformations, in this new form, first I deal with the period change. I divide my x values by 4, and then I would shift it left pi over 4. So in this particular, writing it in this way, this lets me know after the period change has taken place, what is my horizontal shift, or what is, as we say, our phase shift. So in this case, when I factor out the 4, the shift is left pi over 4. And let's see why this makes sense. If I go to my graph, and if there had been no phase shift, but everything else had been the same, then my sine graph would have started at the midline and gone up. So if I think about that, well, how do I have to shift this yellow graph to line up with my red graph? Well, I would shift it to the left, pi over 4, and then it would line up. So it makes sense when I think about the period change, if there and draw what my graph would look like if there had been no phase shift, and realizing, oh, well, if I just shift it left pi over 4, then it lines up with what I've got. So the phase shift, you can report the phase shift after you have factored out that b value. It's still within the sine function, it has to be, but it's just separating out from the x and the phase shifts to really get to see how I've shifted that graph after the period change. Okay, that was a lot. So kind of just to sum up, let's add everything in here, and it can be sine or cosine x. I'll call this one d, I guess, plus c. And again, we can do it for cosine as well. So we said amplitude is a, absolute value of a rather, period equals 2 pi over b. And the interval width, I can get that from the period divided by 4. The vertical shift is up or down c. And notice I wrote the b and the x minus d in this factored out form. And in this form, the phase shift is left or right d. All right, let's do one more together just to kind of get this down. And trying to see which one I want to do with you. And maybe I'll do this one. This one doesn't have a vertical shift, but there's something important I want to I want to say about this particular one. Yeah, so let's do this one. It's going to be a cosine. We'll break it up and make it a cosine here. All right, so let's do y equals 2 cosine x plus pi. All right, so in this case, all right, let's see. Do I want to do this one? Yeah, we'll do this one. The period is 2 pi, still the same because b is 1. Interval width then is pi over 2. The amplitude is 2. No vertical shift. And the phase shift is left pi over 4, which means when I talk about plotting one period, I'm going to start at negative pi over 4. And, that's not supposed to be 2 pi. And then end at 7 pi over 4. Okay, so when I go to my table here, then I've got my x value is negative pi over 4. I'm going to add pi over 2 to get my next angle I'm going to plot. So the next angle would be pi over 4. Adding pi over 2 again, the next angle 3 pi over 4. Then 5 pi over 4, and finally my 7 pi over 4. And it should be the case that when I plug these values in for x, I'm really graphing 0, pi over 2, or not graphing, I'm really evaluating 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now when I take the cosine of these, I know that the cosine of 0 is 1, 0, negative 1, 0, 1, and then just multiply these y values, the ratios, by 2. So 2, 0, negative 2, 0, 2. And the reason I want to just show you this graph is, in particular, is I want to show you just to be careful about when you are plotting your points. So we said we're going to plot negative pi over 4. And then the next one I plot is pi over 4. Now notice the interval width between the angles I plot. It's this right here. So my distance between my next angle I plot should be this same distance. So should be around there. So just be careful with your interval width. Pi over 4 and 3 pi over 4 are not pi over 4 apart. So that should not be the same as the distance between 0 and pi over 4. So I've got 3 pi over 4. I've got 5 pi over 4 and 7 pi over 4. And then I could extend it in the negative direction too. A little bit if I want. Negative 3 pi over 4, negative 5 pi over 4, and negative 7 pi over 4, just to extend it a little. All right, so now I'm just going to erase that. All right, so we said at negative pi over 4, I'm going to be up at 2. And then at pi over 4, 0, negative 2, 0, 2, and continuing the other way here. So it indeed does look like, and it should look like, a cosine graph shifted to the left pi over 4. All right, so that's a very systematic approach to doing this, but I do find it sometimes helpful to, one, if you do this approach, you can graph any sine and cosine function thrown your way. Some, of course, may not be so fun, especially if fractions involved. And the better you get at this, the better also I feel like it'll be when in the next video I talk about, okay, here's a graph. Let's find a sine and cosine function that describes that graph.